mistakes in these slides. I'll try to point them out as I go along. I'm sorry. On Thursday, we talked about the basic theory of oligopoly, and today we're going to talk about sort of the biggest area to which this theory is applied, which is the control of mergers. So we'll start by talking about Cournot equilibrium and stability in Cournot equilibrium and the comparative statics of that, and how we can use that to think about the effects of entry by a new firm into a Cournot industry, and therefore how Cournot competition drives prices to cost. We'll then talk about more general ways in which competition may drive prices to cost, as well as empirical studies of the effect of competition on prices. We'll then talk about mergers in differentiated products industries and the concept of upward pricing pressure, as well as the legal and institutional basis of merger policy in the U.S. and around the world, and common policies that these agencies, common approaches that these agencies take to analyzing mergers, some of the challenges that merger policy faces going forward, as well as what things are currently left out of merger analysis that should be included. So recall that comparative statics go completely nuts if the equilibrium is not stable, right? So like an increase in supply would actually lead to a higher price if we weren't in a stable market equilibrium, right? So what is the appropriate notion of stability in Cournot competition? Well, remember that on Thursday we had these reaction functions, which were like how much does this firm want to do if the other firm does a little bit more, produces a little bit more. If they cross in the right direction, then things converge. So imagine that one firm increases its quantity by a small amount. How much, in the language of the reaction functions, where the quantity I produce is a function of the quantity the other firm produce, is Ri, how much, Edgar, would the production of firm I change when the production of firm J increases?
Wait, can you please describe the function that we're dealing with?
Okay, so we have this function Ri of 2J, which says how does firm I's production depend on how much firm J is producing, right?
Oh, if because Qi is a function of Qj.
Exactly.
So it would just be the derivative of whatever that function is.
Exactly. So it's just Ri prime, right? So Ri prime is how much when Qj increases, Qi will increase. Now, how much does, so that's the first effect. So Qj rises, that affects Qi. But now that's going to have some follow-on effect on Qj, right? And Osama? Is Osama here? No. The effect that that's going to have on Qj, right, is again just Rj prime, right? So the total effect, so if you think, okay, Qj increases, that affects Qi, that in turn affects Qj, so you multiply those two things together and you get Ri prime times Rj prime, right? So when is this going to converge? When is this going to lead things to actually, slow down eventually? Botao? Botao, when is this process going to converge? So if Qj increases, that causes Qi to increase. That causes, Qj to increase by this amount. When is that process going to converge, or when is it going to blow up? Well, so if Qj increases by 1 unit on the first round and then changes by this much on the second round, under what conditions will that eventually decrease, and at what conditions will that blow up?
less of a thought?
Yeah, Eric?
That's less than what?
Yeah. So, yeah, so why is that? Well, if, it increases by twice what it increased by the last time, then it's just going to keep getting bigger and bigger and bigger each round, right? And so that's going to cause things to blow up, right? Now, luckily, the second order conditions for a monopoly, just that the marginal revenue curve is decreasing relative to the marginal cost curve, is going to be enough to ensure this. So as long as we assume that the marginal cost, the derivative of marginal cost, is greater than the derivative of the industry marginal revenue curve, everything will be stable. And so you just have to make sure you check this whenever you're solving the problem. So otherwise you'll get very silly comparative statics, like that one firm increasing its production could cause the total industry production to go down. It's basically the same as in competitive equilibrium. So just to graph this, before we had a picture sort of like this. So if the product of the values is not less than 1, then if this is Qi, and this is Rj of Qi, and this is Ri of Qj, and this is Qj. So imagine we start at a particular Qi. We then figure out how much Qj that corresponds to. We then figure out how much Qi that corresponds to. This is nice. It's converging towards the thing. But if instead we had something where, say, we reverse the roles of these two things. So this was Ri of Qj, and this was Rj of Qi. So Ri of Qj, okay, so we would go from here to here, and then we would say, okay, how much Qi would that be? That would be here, and it would be like this, and it would go crazy off in that direction, and if we were above, it would go crazy off in the other direction. So this thing just corresponds, like in competitive equilibrium, to these things tracing a path back towards equilibrium. Okay. So once, if one firm increases its production, this should always raise the total production of the industry. But exactly how much is it going to do that by, Edwin? Edwin Oliva? Well, it's going to increase it by the initial amount that the firm increased by, which is 1 unit, plus whatever the change in the other firm's production is, Ri prime, right? So it's going to be Ri prime plus 1. And this is the same, let's assume that the firms are symmetric, then this will be the same for the two firms. And this number is called the quantity pass-through rate, rho Q. The reason it's called the quantity pass-through rate is it's exactly equal to the pass-through rate, but I'm not going to, I talked about that in the turbo section, I'm not going to talk about that here. So the stability condition is going to be the same as saying that the quantity pass-through rate is less than n over n minus 1. So what if there were what if there were 3 firms and one firm raised its production? What would happen? Well, the total increase in production, let's call that d capital Q dq tilde. That's going to be the amount by the third firm that's coming in. Well, each firm is going to have to increase its own production by 1/2 of the amount that the total industry changes, minus 1, which is the direct increase by the new third firm, right? And that has to be consistent with the quantity pass-through rate. So the amount that the total industry's production changes when the new firm increases its production is the amount that all other firms increase their production times the pass-through rate of the last firm in the industry. So if we just think about one of the firms, there's a total amount that all the other firms are increasing their production, both from this outside firm and from the firm that's in the industry. So how much is that? That's 1 from the firm that's outside that's increasing its production, plus however much the other firm changes its production. And if we then distribute this through, we get 1 minus the quantity pass-through rate over 2 times d capital Q d Q tilde is equal to the pass-through rate over 2. And so we get that the amount that the industry increases when this third firm increases its production is the quantity pass-through rate over 2 minus the quantity pass-through rate. More generally, we can use the same logic to show that when there are n firms, the amount that the total industry production increases when some firm who's outside the industry comes in and produces something is the quantity pass-through rate over n minus 1 minus the quantity pass-through rate. So, the most important point is that this thing is always going to be positive whenever the stability condition is satisfied. And that means that if a new firm enters the industry, it will always raise its production, because initially the firm isn't in the industry. It's now entering the industry. That's raising its production from 0. And the impact that this has on total production is what, Michael? How much is this new firm increasing its production going to have on the total production of the industry? We just did it on the last slide. It's like for 3 firms in the industry, or for any number of firms, right? Well, it's just what we derived on the last slide, right? If a new firm enters, and that's the n plus first firm, right? Then it's just going to increase the total production of the industry by this amount that we derived here, right? The point is that if the new firm is going to produce something, it must raise the total production of the industry by the amount we derived here. Yeah, go ahead.
I have a question about the last line where you have the term n over n minus 1.
Yeah.
In the line before that, you have the number 2, but I don't see how that makes sense given that n is equal to 3 in that specific.
No, so this is the number of firms before the new firm enters. So you could also make this n plus 1 over n if you want to think about the Okay. So this increased production will drive down prices because demand slopes downward, right? And thus the new firm is going to make the industry more competitive, right? And this is a more general feature. As firms increase, the industry becomes more competitive, and we get towards perfect competition. So let's consider a specific example of this, which we used in class the other day: constant elasticity, demand, symmetric cost, and constant marginal price cost. So we know that each firm is going to set price plus quantity times the derivative of price equal to cost. Let's assume symmetry, so each firm is going to produce the total quantity of the industry over n. So you get this equation. And Broca, could you convert this expression into an elasticity? This one here.
P.
Yep.